Any questions on the homework? Morgan.
Number
23? That's all right. She'll pay for it later. Actually, double. 23. Because it's getting very hard to read the display, I'm going to get a new bulb. All right. 23. On 23, it's in fishery science. Cohort is a collection of fish results from one. Reproduction assumed. There's your equation. Assume that the number of fish in a T is still alive after T years. So that's live fish. Approximate the percentage of the original number still alive after 10 years. All right. Let's see. Did anybody else do this one? Yeah, I give you enough information. You just got to make up your own number sometimes. So, let's say an easy one to start with is 100. Well, if it's a percent change, sure, any number you start with, the percent will stay the same. It doesn't ask for the actual number left, it asks for a percent of change. So if I start with 100, that's an easy one because wherever I end up with, that would be my answer, right? So 100, e to negative 0.2 times t. If you put in 10, 0.2 times 10, what do you get when you punch it out? 13. Interesting. There we go. View. Second quit. 100. Second e to negative 0.2 times 10. So it said, yeah, 13.5. So if that equals 13.5, that means that would be the percent still remaining after 10 years of that original cohort. Now, I don't know, is that even close to being right? 13% of the original number still alive. Still alive. Okay. Anything else?
Yep.
I have time for one more. Is that it?
Yeah. We have time for one more.
33.
Yep, sounds good.
All right, moving on.
Why do you all have time for one more?
I've got things to do.
People say things to do.
33.
Yeah.
That's one of the things I have to do.
Which one?
33. Oh, the effective annual yield. This one's interesting because you actually get to use an application on your calculator in which you didn't know was there. EFF, I'll just do part A. Continuously, I'm not going to do because your calculator can't do it. You wouldn't do that normally, so I'm going to do quarterly. Quarterly means it's actually done every, let's see, 3 months. So N would equal 4 on your equation. If you go to your calculator, EFF is the first 3 letters. This is a financial application. It's saying, what does 7% interest rate compounded quarterly actually equate to if you just did it annually? In other words, what's the same number since it's not been compounded so often? So if you go to the apps, APPS, if you have an 82, you can't do this. So just sit out and watch. Apps, then you go to finance. It's a financial question. Apps, finance. And then you go to down to where it says EFF for effective annual yield.
C.
And there it is, EFF. And you press enter. And then you type in, this is the one time, since you went to the financial model, this is the one time you don't have to put in the percent as a decimal because you went to the finance applications. In finance, they don't type it in as decimals. They type it in just as regular numbers. So I can put 7, I can put a comma, and then how many times it's compounded. In this case, it's compounded quarterly. The effective annual yield of 7% compounded quarterly is actually 7.18% compounded annually. Okay?
So you typed in 7 was,
There's a comma.
7,
was all.
and then comma, then 4, and EFF. If you take business calc, if you take business stats, any classes like that, you'll use that financial apps a lot. And in fact, they'll give you programs on their website for you to update your computers or your calculators with flash memory. Okay? So you'll be using their programs and the ones that come with your calculator for solving questions. Excellent. I like that one.
Hello.
Good. Moving on. It is Friday. Next week starts an interesting week with a quiz instead of a test.
When is that?
The quiz, I don't know. I'll have to check the website. I think it's Tuesday, I think. Anyway, Math 124.44, logarithmic functions. Way back when, yeah, way back when, they were working with exponential functions, y equals a to the x. And they said the domain was all real numbers. They said the range had to be all positive numbers. All right? And they were, you know, doing pretty good. Exponents have been around for a long time, a couple hundred years. Saying life was good. And all of a sudden, one day somebody said, what happens if I have a y and I want to find x? Do you remember what type of function it has to be before it has an inverse?
Is it 1-to-1?
1-to-1. It has to be a 1-to-1 function, or always increasing or always decreasing. So, exponential functions are 1-to-1 because we said a had to be positive. Okay, we also said a cannot equal 1. Those are a couple of characteristics of that. So, somebody goes, what's logical? You just do some arithmetic and you get the answer. Well, through a series of writings, the words logical and the words arithmetic became one word. People started abbreviating, then the spacing got cut down, so logarithmic actually means logical arithmetic. And it wasn't very arithmetic. It wasn't very logical to a lot of people. But the main players at that time said, look, this is the way to do it. It worked. They moved on. Life was good. So this is a result of solving for y or x when you know y. You have to do the inverse. Okay? And we all know that the inverse of a log is if you have, well, see, that's kind of wordy. I never did like that definition. If you have, this is your function, f of x, y equals a to the x. You know that a has to be positive and it cannot equal 1. Okay? You know that the domain has to be all real numbers. And that the range has to be positive. Okay? So for your inverse, you switch x and y and you solve for y. So what's the base of this exponent over here on f of x? It's an a, isn't it? All right. So somebody said, well, logically, a is going to be the base of my new expression. Not too difficult. And then I'll have, you know, I'm given y, so I'll just manipulate y logically, and I'll get my answer for x. So I have log base a of y, that equals x. Remember the last step is to replace it. So what they did was they said, okay, look, our inverse actually equals log base a of x. X becomes the y becomes the x, everybody's happy. What is the domain of this function going to be? Yeah, x has to be greater than 0. You can't take the log of a negative number. What does a have to be? No? A, the base. Right, it can't equal 1, and A also has to what? Has to be positive. That fact remains as well. And then what's the range going to be? Yeah, the range is going to be all real numbers. So, as long as you remember they're inverses of each other, and somebody goes, well, why do they use the word log? Well, they were saying it was logical. Just take this, run it through this system of operations, and you'll get your answer. Anybody can do it. Well, not anybody could do it, and there are some problems later on. But they handled those problems quite well, and it survived the tests, and now today we have logarithms. Anyway, the basis is what's unique, and so is the domain. It's kind of different. Your calculators are set up for 2 bases, which you have log. You have the log button on your calculator. That means base 10. You also have the ln button on your calculator. That means base E. Okay? So if you have a log base E or a log base 10, you know which button to use. That's the only base buttons you have. These aren't Casios or Sharps or anything where you can change the numbering system to different bases. Thank goodness. That causes more headaches than you can know in high school. But anyway, it's important you understand the direction say it wants it in log form. It physically wants the word log in the answer. If it says exponential form, it physically wants an exponent in the answer. Okay, this is an interesting chart. It's one of the few charts I've seen like this in a textbook. That's in your textbook. They actually try to spell it out very clearly. I just remember that the log is the inverse of the exponential function, and I move on. The inverse is easy because everything just switches. You know, the x's become y's, y become the x's. The a has to be the same because it doesn't change. So that's good. And the hardest thing you have to do is remembering what you were taught, and then applying it with the graphing calculator. All right? So, these are all situations. These are just examples. These are listed, actually, I think, in your textbook. You don't have to write all these down. More or less, just think about them. How you say log base 5 of 2. Well, if you look over in the exponential form, what's the base? Oh, sorry, log base 5 of u. My fault. Log base 5 of u. In this one, what's the base of your exponent? 5. So, you know, if you read it correctly, it's fine. For instance, how would you read the example on the left right here? Andrew, how would you read it?
Log base B of 8.
Right, log base b of 8 equals 3. And you can kind of figure out what that base is going to be. It's pretty logical. What's b going to equal? 3. Or 2, I'm sorry. B is going to equal 2. Okay? Nice. And it's logical arithmetic. That's all it is, multiplying and dividing. Yeah, next one is fun, but we're not going to solve it today. But those are just some examples of how the base is shown to be the one thing that you probably start with first, your basis. All right? All right, let's get to solving some questions. Oh, I don't really memorize these. I don't know, does anybody memorize properties of logs just for fun?
Oh, yeah.
I guess if you're snowed in, you got nothing else to do, you can memorize properties of logs. Yeah. This is, pretty easy to get. If I asked you to punch this one on the calculator, you couldn't do it yet. My goal is to get you to be able to do it after a while. Now these next two, these are the ones that are used a lot in calculus. I would make a note of these two. They are used a lot in calculus. Okay, these two. In fact, they have a whole section of problems before they get to the calculus part that says, remember, this is how logarithms work, and these two are very important. So they highlight these. Yeah, the log base a of a. Remember, you can bring the x out in front, right here. And this one is kind of interesting because people don't think of a log as being a number into an exponent, which it is actually. So that's kind of cool. Okay? Oh, I got to switch the lighting. It's hard for me to see. If it's hard for me to see, it's got to be hard for you to see. There, that's better.
Well, that was much better.
Thank you. All right.
So how would you say, wow,
A raised to the power of log base A of x is equal to x. Correct. It does. Yep. Okay. What are these? Oh, logs are 1 to 1. Talked about that. Talked about that. Logarithmic function base. Thus, the following equivalent conditions are satisfied. Oh, that means it's 1 to 1. Nice. Moving on. We already talked about that. You got to take the log of a positive number. In this textbook, they reserve the right to call common log in word problems as base 10. Okay? In this textbook, when you see the word common log in a problem, it means base 10. In this textbook, when you see the word natural log, it means base E. Okay? They reserve the right to use that because in calculus they use the words common log and natural log a lot. So, common log base 10, natural log base E. We already talked about you have this button on your calculator and you have this button on your calculator. If I heard it once, I've heard it a lot. They forgot to write the base. If it's not written, it's 10. If they want to change it, they'll write an E right there. And that is not, that's Latin. LN is Latin for natural log. Okay, it's a Latin expression. All right. Ready? I want to solve some problems so bad. There we go. This isn't solving problems. What's the base of this exponential equation? There you go. Log base 3 of 243 equals 5. Now, how do you know if you did it right? How do you check it? There's how you check it. You can either check it one of two ways. You can check it like the high school kids that you are this semester. Some of you next semester will be like college kids. You can check it that way as well. Makes no difference to me. Yes? Yeah, it is. It is 243. All right. So, I don't care how you check it. I don't care which way you check it. But obviously the college kids do not revert back to high school ways. Well, yeah, but you're not in college yet.
Except for the ones that drop out.
All right.
we're trying to get the best out of every.
All right, the most out of every day. I like it. Making suits. Nice. You take the log of 243, huh? Don't you agree? Get the most out of every day? Exactly. Log of 243 divided by log of 5. Go ahead. I'm not going to tell you the college way until later. You can only handle one way at a time.
Can't handle the truth.
Oh, it's log of 3, not 5, 3. So, log of 243. 243 divided by the log of 5. You did it right.
No, it's log of 3.
Oh, yeah, log of 3, sorry.
Which equals 5.
Yeah, 5, you did it right.
Thanks.
Nice. See? It all works out. Second enter. Enter. There we go. I just used to change the base formula we'll talk about later. All right, you want to know the college way?
Yep.
Really?
Yep.
All right, I'll tell you. It is ln of 243 divided by ln of 3.
What's the really?
Yep.
Wow. You changed it.
ln
We learned that last year.
243. Yeah, but you don't know why it's the college way. ln of 3.
Why is the college way?
Oh, it's the college way because it's Greek. Colleges are very Greek.
Oh, like the
Fraternities, sororities, there you go. Oh, I get it. Thank you.
sneaky.
Thank you very much. Have a nice day. All right. So, on this next one, what's the base going to be? This one? Base is going to be what? 3. So log base 3 of 1 over 81 equals -4. I'm not going to check it out. I just wanted to show you how you can punch things out on the calculator that have a different base, in case you want to check them at a certain time. And that one's obviously log base C of D equals P. Okay? Should be a piece of cake. Very easy. This one. How do you write this one into exponential form?
4.
Yeah, 3 to the 4th equals 81. And this one,
4 to
So that's pretty easy to check. See if you did it right. Okay? Not too difficult, just a little. That was easy. Just not too difficult at all.
Or 1 over 256.
Yep, 1 over 256. So it's 6 to the third equals 2x minus 1. And you can solve that for x later on. All right, moving on. Solve for t using logarithms with base a. You cannot take the log of both sides. We haven't done that yet. You're going to have to rewrite this. And remember, exponential form means you have no number in front of the a. So you have to get rid of the 3 first before you can rewrite it.
3 out of 10.
Right. You're going to take 10 divided by 3. So you're going to have a to the 4t equals 10 thirds. Once you have the 10 thirds, now you have it set up. You have a base. You can only use 3 parts when you're doing this. You have an expression, and you have your exponent. Here, up here, you got 4 parts. You can't have 4 parts before you rewrite it. You can only have 3. Now I'm good to go.
So it's just log base a of 10 thirds.
Right, log base a of 10 thirds
So the 4t.
equals 4t.
So you got to divide them 4 over.
Yep, because it said solve for t. So 4t is equal log base a of 10 thirds. That means 1t would equal 1/4 of log base a of 10 thirds. Okay? Yes?
So earlier you said you could bring exponents out in front of.
Sure. If you want to get fancy, you could bring the 1/4 back up. Log base a of 10 thirds to the 1/4 power equals t, if you want to get fancy.
Okay, I just couldn't remember. So I always remember just bringing something up in front. I didn't know where they.
You can do that, but this is fine. Okay?
Thanks.
No problem.
Is it worth simplifying and then up to the front?
It depends on what you're doing it with. It depends what you're doing with it. If you're combining or if you're solving. It depends. Right. 20. All right, perfect. We'll do this one, then we'll move on. Oh my gosh, look at this. Easy.
Yeah.
There's so many different things to do. You have to remember the order of operations on how to solve it.
Wow, sweet.
So what do? You add the p over. L plus p. What do you do next?
Divide by, I divide by m.
Right, divided by m.
Yeah.
L plus p divided by m.
Yeah. So then you log now.
I have my,
Not like, is the exponent like t divided by m? Is that
yeah, it is. If you had to put it in the calculator, you have to put parentheses around it. So we have that. We got our 3 players. We got our exponent, we got our base, we have our expression. So now we can write it. Log base a of L plus p divided by m equals t divided by n.
Can we bring the n out? What? No, bring the n over, right?
Multiply both sides by n, right?
Right, and then can you take the m out of the thing and make it.
No. We'll just leave it like that. Yeah, we'll just leave it like that.
Wait, what did you do?
I'll multiply both sides by n. Okay?
1 through 9, there we go.
Multiplied by n. Multiplied by n. All right? Fantastic.
Moving on.
Moving on.
We're getting the most out of it.
We are.
I
I like that.
I talked to somebody and said, Karen, they're not excited about it.
No, they're not. Pay. I told you they weren't. Page, what page?
325, 1 through 9.
325. Are you sure?
Well, we last meeting is 10, that's the last part of the section, but if you want to say the most, we can do it.
Yeah, get the most out of it. This is your homework. We have a quiz next week. Probably review or do something. Your quiz will be on Wednesday, actually. 7th hours will be on Tuesday. Yes.
So, like, when you guys are doing the final review study,
Stay out of my way. All right, 5 for 10. What section is it, Andrew?
Yeah, 420.
Which page is that? 299?
We went up to what?
Well, up to 47?
Yeah.
Well, that makes it easy.
Let's do 1.
No.
1, 3.
We'll do 7. We'll do 7, 14, 21, 28,
This last time.
35. All right, very good. I need to stop this.
Oh yeah, the people who on the recording can do this for extra points.
They can't.
So if I go do it tonight, can I get?
No, you're here now, silly. All right, you got the remaining time. Some people turn it in, yeah, and I grade it. Huh?
I did that
Yeah.
once.
Ready? All right, have a nice day.